Hello everyone. Good afternoon to all guys. Just let me know in the chat box whether my voice is clearly audible or not and my screen is visible clearly or not. Okay, I'm launching the polls. Just respond to the polls. My voice is coming clearly or not and my screen is visible clearly or not. Guys, can you please respond in the chat to the polls? Yes. Anyone? Zenbi Krishna, Zenbi Mai, Gondia, Zenbi Karimnagar. Guys, can you please respond to the polls? Everything is okay? Okay, done. Okay, I'm on ending the polls here. Okay. Oh. So this is actual lecture 2. Okay. So it's good to start the class. Okay. Hello everyone. Good afternoon to all. Welcome to the class also. How are you all? Okay. So yesterday we have completed the first lecture of complex number. Okay. So today we are going to start. Actually, in the previous class, in the last class, we have just covered all the basics of concept complex number. Okay. So in this session, in the second lecture of complex number, what we are going to do actually, we'll cover how to find the square root of a complex number. Already I told you about how to find the square root of a complex number in the last class also. I told you, I discussed the methods of how to find the square root of a complex number. But now, and also I gave one questions also. How many of you tried these questions? Okay, no need to worry. We'll solve that. Okay, and then secondly, we'll try to find modulus and conjugate of a complex number. And then we'll find argument of a complex number. Then in lastly, we'll see how to find the polar form of a complex. All of you know all these things, and because of your CBSE board exam is coming, so on the CBSE board basis only, we'll discuss the questions or we'll cover all the concepts, which will be helpful in your board exam. Okay, so let's start from how to find square root of a complex number. I already discussed the method with you in the last class, guys. Okay, yes or no? Enough? Okay, suppose you have a complex number, this z is equal to x plus iy. And if I'll ask you to find the square root of this complex number, that is on root of z, or we can say on root of x plus iy, then what it will be? What is the answer? How to find? We know how to find the square root of a real number, but how to find the square root of complex number? It's little different. Okay, so first of all, what should you do? Let's take this on root of x plus iy is equal to a plus ib. Okay, because on root of a square or on root of a complex number again gives you another complex number. That's why I'm taking this on root of x plus iy as a plus ib. Is that clear to everyone? Okay, now if we'll square both sides, if we'll squaring both sides, then what you will get? X plus iy is equal to a plus ib whole square. And we know, just open this whole square or open this identity. So what you will get? A square, and I know I square is -1, -1. That means ib square is minus b square minus or plus 2ab. Right? So here I'm getting an equation which is x plus iy is equal to a square minus b square plus 2aby. So now in the right hand side of this equation, you can observe there is also a complex number, which has the real part as a square minus b square and the imaginary part as 2ab. So if you compare both sides, what you will get? By comparing both sides, I'm getting here x is equal to, I already told you in the last class, x1 plus I y1 is equal to x2 plus I y2. If we'll solve these equations, what that means? These two complex numbers are equal. That means x1 is equal to x2 and y1 is equal to y2. So similarly, here also we can compare and we can say also x is equal to a square minus b square and y is equal to 2ab. Now if we'll solve these two equations, by solving these two, you will get the value of a and b. Okay, by solving 1 and 2, we can get a and b. Now after finding the value of a and b, just put here and you will get the square root of x plus y iy, which is a plus ib. Is it simple or not? Yes. Everyone respond in the chat box. JNB Warangal, JNB Krishna, JNB Mai. Yes. Is that clear? Okay, let's solve one example. Okay, try to find the square root of 7 minus 24i. So what is the method? Just apply the method and tell me what is the answer. Okay, I'm launching the poll and I'm giving you 1 minute for these questions also. Just I'm launching the poll. Respond in the polls. What is the answer actually? Guys, please try it and respond to the polls. How can we find the square root of 7 minus 24i? What is the answer? Which of the following? Anyone got the answer, guys? After getting the answer, just respond to the polls. Yeah. Did you got the answer or not? Yes. So it's time. Okay. So some of you answered the option D is the correct. Let's check what is the answer. Okay. See, here we have the complex number as 7 minus 24i, and we need to find the square root of this. So what is the first step? First step is let's assume this under root of 7 minus 24i as a plus bi. Now if you square both sides, what you will get? 7 minus 24i is equal to a square minus b square plus 2abi. Yes or no? Now if you compare both sides, we are getting a square minus b square is equal to 7 and 2ab is equal to 24. That means ab, we are getting ab as 12. Right? Now, if you solve these two, then what you will get? What is the value of a and b you are getting? Now tell me in the chat box, what is the answer? Solve these two. A square minus b square is equal to 7 and ab is equal to 12. By solving these two, what are the values we are getting? We are getting one is a is equal to, a can be 4 or sorry, a is equal to 4, one is a is equal to 4 and b is equal to minus 3. Let's check. A is equal to 4, b is equal to minus 3. Okay, that gives you minus 2. Oh, sorry, 2ab is equal to minus 24, right? So ab is equal to 12, and that means a is equal to 4 and b is equal to minus 3. I did have mistake. Okay, and another option, another answer I am getting, that is a is equal to, you can take minus 4 and b is equal to 3. You can check for both answers. If you take a is equal to 4, here you can get 4 square is 16 minus 3 square is 9. Okay, that is 16 minus 9 is 7. Similarly, you can put these two values also. Then what is the square root of under root of 7 minus 24 I you are getting? That is the answer is under root of 7 minus 24i is equal to plus or minus 3i minus 4. So option D is the correct one. Is that clear to everyone? Option D is your correct answer. Clear? Okay. I hope this is clear to everyone, guys. Okay. E2 guys, also you can respond in the chat box and checking it also. Okay. Sure. Okay. Now we'll learn how we can represent the complex number. We know how to represent the real numbers on the number line. All of you know now how we can represent the real numbers on the number lines. So similarly, how we can represent the imaginary numbers on the number lines. So this is the way. This is the way. So this is my 0, I, 2i, 3i, and so on. Similarly, in the left hand side of 0, minus I, minus 2i, minus 3, and so on. Right? Is that clear to everyone? So this is my imaginary number line. We can say this is imaginary number line. Right? So now we'll learn organ plane. What is organ plane? Anyone can say what is organ plane? So where we can represent the complex number. That is actually organ plane. Okay, so actually what he did, actually we know what is real axis, real number line, and we know what is imaginary number line. So if we take this imaginary number line on this vertically, if we place that imaginary number line on the real number line vertically, then that will give you like this figure. Okay, like the Cartesian plane. Is that or not? So if we'll take this as my real axis, x-axis as my real axis, and y-axis as my imaginary axis. So in organ plane, in Cartesian coordinate system, we know x-axis is my represent for the real numbers, positive real numbers, and y-axis represents for the negative real numbers. Right? Similarly, in the organ plane, x-axis represents for the real axis, or we can say y-axis as my imaginary axis. That means on x-axis we can plot the real numbers, and on the imaginary axis or on the y-axis we can represent the imaginary numbers. Is that clear to everyone? Yes. So actually, this is my organ plane. Actually, in the coordinate geometry, we called that was actually, what is that? Cartesian plane. But in case of where we can represent the complex number, that plane is called actually organ plane. Is that clear? Or we can say also complex plane. Yes. So how we can represent the complex number in an organ plane? Suppose I am taking a simple number, a simple complex number, that is 3 plus 2. Suppose I am taking z as my 3 plus 2. Okay. So how we can represent 3 plus 2i? That means to reach this point, actually complex number is nothing but it is a number only on the organ plane. Complex number is a point in the organ plane, nothing else. Okay. So z is equal to 3 plus 2i. So how can we plot this point? How can we plot these points? That means on x-axis we need to cover 3 units distance. Okay. On x-axis or real axis, we need to cover 3 units distance. Then on imaginary axis, we need to cover 2 units distance to reach this point. Then we can say this point is actually a complex number, which is 3 plus 2i. Similarly, also we can take another example here, minus 4 plus 3i. That means on real axis, I need to cover 4 units on negative real axis. Okay. And then to reach these points, also we should cover 3 units on positive imaginary axis. Clear? Then we can reach these points, and this is actually my complex number, which is minus 4 plus 3i. Is that clear to everyone? Guys, clear now? So let's move. This is all about organ plane. Okay. Now, Cartesian form. What is Cartesian form? All of you know. And every complex number z, suppose I'm taking z is equal to x plus iy, can be represented by a point on the Cartesian plane known as complex plane. Similarly, already we discussed this thing. Suppose I am taking any complex number, that is jx plus iy. So that can be represented in the Cartesian plane or known as, that is actually complex plane, right? Complex plane में हम ये जो x plus iy को represent कर सकते हैं, और we can say organ plane also. So suppose that means we need to cover x units on real axis, then we need to cover y units on imaginary axis, then we'll plot the point that is z is equal to x plus iy. Okay, so this is the point z is equal to x plus iy. Okay, and we can say this is my z is equal to x plus iy. This is my Cartesian form of the complex number. Cartesian form. This form is called actually, what is that? Cartesian form of complex number. Clear everyone? Done? Chalo, ठीक है. Okay. No. Okay. So since a complex number are representing points in an organ plane, they cannot be compared to check which one is bigger. Okay. So that means if you have two numbers or complex numbers, suppose I'm taking x1, z1 is equal to 1 plus 2i, and z2 is equal to 2 plus 3i. Okay, so we cannot compare these two numbers. That means we cannot say which one is bigger or which one is smaller. We never say. That is wrong actually. We cannot compare two complex numbers. Which one is bigger or which one is smaller, right? Why we cannot compare? Because they are represents to a point in a organ plane. You can see here now. Suppose this is my organ plane and this is my 1, 2. Okay, and this is 1, 2, 3. So if we'll plot the first number, that is z1 is equal to 1 plus 2i. That means here 1 plus 2i. So this is the point. That is z1 is equal to 1 plus 2i. Okay, and this is the point 2 plus 3i. That is 2 plus 3i. This point is z2 is equal to 2 plus 3y. Okay, so these are 2 points only in the organ planes. So we cannot compare between 2 points. I cannot say this point is bigger than this point. This point is smaller than these points. So this is not the way to compare 2 points. We cannot compare 2 points which is bigger or which is small. Yes, but one thing we can do, we can say this z2 point, present. So this distance from origin, this distance from origin to point z2 is bigger than the distance from origin to z1. We can say. Okay, here we can say the distance from origin to the point z2 is bigger than the distance from origin to z1, or we can say z2 is situated at the point place from where origin is bigger than z1 is situated at the peak. Yes, is that clear to everyone? So the conclusion is we cannot compare two complex numbers. That means we cannot say which one is bigger or which one is smaller, because they represent to a point in the organ, and we cannot compare points. Is that clear to everyone? Guys, just respond in the chat box if it is clear to all. Yes, done. Shall I move to the next thing? Yes, sure. Let's move. Now, how we can find the modulus or distance from origin to a complex number? That is modulus. What is modulus of a complex number? Modulus is actually the distance from origin to the complex number. Okay. Suppose I'm taking a complex number z, whose coordinate is xy, or we can say z is equal to x plus iy. I'm taking. This is my complex number. Okay, so if we'll plot this complex number here, suppose this is my point, or this is my complex number x plus iy, and if we'll join from this point to origin O. Okay, so this length OP is called my modulus. Okay, simple. Okay, chalo. So how we can represent, how we can find the modulus? Let's understand that thing. So if you drop a perpendicular from the point P on the real axis and name this point as M, suppose. Okay, done. Here you are getting what you are getting. You are getting a right angle triangle. OPM, right angle triangle. In OPM, right angle triangle you are getting. If I'll ask you to find, or if you'll use the Pythagoras theorem, that means the coordinate or this point is Z is equal to X plus IY. That means the coordinate of the point P is XY, because OM is the length X and PM is the length Y. The length of OM is X and the length of PM is Y. Because to reach these points, I need to cover first from O to M, that is X unit. Then we need to cover on Y axis or on imaginary axis also from M to Z, that is Y unit. Is that clear or not? Yes. Clear? Sure. If you use the Pythagoras theorem, if you apply the Pythagoras theorem, now can you say what is the length of OP? So OP actually we are getting, suppose I am taking OP as a let. OP is my R. Okay, so OP can be is equal to OM square plus PM square. Yes or no? So OP is actually R. So R is equal to X square plus, sorry, R square plus OP square. Na? R square is equal to X square plus Y square. That means R is equal to, we are getting R is equal to under root of X square plus Y square. So similarly, we can say, or similarly, that means hence we can say the modulus of a complex number. Modulus of complex number Z, which is X plus IY, is actually, suppose the this length is OP, that is R is equal to under root of X square plus. Remember, if the complex number is X plus IY, then the modulus of that complex number is under root of X square plus Y square. Is it clear to everyone? Just respond in the chat box whether it is clear or not. If you have any doubt, you can ask. If you have any doubt, you can ask. Quick. No doubt? Just a minute. Okay. Sure. So this is all about how to find the modulus of a complex number. Now we'll try to find conjugate of a complex number. What is conjugate of a complex number? That is actually image in x-axis. Conjugate means, conjugate of a complex number means the image of that complex number in x-axis. Yes. So suppose if you have a complex number Z is equal to X plus IY. So the conjugate of Z actually denoted by Z bar. Remember, conjugate of a complex number represent, if the complex number is Z, then that conjugate of that complex number can be represented as Z bar. Clear? And it will be X minus IY. Okay, just in case of plus, you need to change the plus sign to negative sign. Then you will get the conjugate. Okay, that this is the method. Why I'm saying like this, Z is equal to, if Z is equal to X plus IY, then conjugate of Z is equal to X minus IY, or Z bar is equal to X minus IY. Yes, that is similar work. That is same as saying that image in x-axis. Suppose here you have the point Z, whose coordinate is, or we can say this complex number is X plus IY, or we can write also this was coordinate wise XY. Yes. So if this OZ, actually complex numbers behaves like a vector, because see you can see here in vector also you have studied already in physics also. To reach these points, what you do? What you are doing? You need to cover this on x-axis, then you need to cover this distance on y-axis to reach this point. This is the behavior of a vector actually. So if I ask you to find the image of this point z in x-axis, and this vector of this complex number makes an angle theta with x-axis. Okay, if this angle theta, if this complex number makes an angle with x-axis is theta, then the conjugate of z will be making an angle with x-axis in clockwise direction. This is the anti-clockwise direction and this is the clockwise direction. That means this will make an angle with x-axis minus theta. Z bar, conjugate of z. If z is making an angle theta with positive x-axis, then z bar will be making an angle of minus theta with x-axis. Is that clear? Done? Then if you'll observe, or you can observe here, if the coordinate of this point is xy, then this point will be, tell me, x minus iy, or x minus x plus, we can say here. This point can be written as x minus iy or x minus. Yes or no? So this is conjugate. Simple things. If you have any number, suppose I am giving you one number 7 plus 8y, then z bar will be 7 minus 8. Okay. Instead of plus sign, if you take negative sign, then it becomes conjugate of that complex. Clear, everyone? Clear? Done. Sure. Let's move to one question, guys. Okay. Here you have a question. If 4 complex number, it's a questions of 2020 JEE Mains. And if the 4 complex number z bar minus 2 into real of z bar and z minus 2 into real of z represents vertices of a square of side 4 unit in the Argand plane, then you need to find the modulus of that complex. Clear? Okay. So to solve these questions, first I will assume let the complex number z is my x plus iy. Then the second number will be 4 complex number we have now. Then the second complex number will be conjugate of z, that is z bar, it is given. So this becomes x minus iy. Clear? And if this is my z bar, then the third number is z bar minus 2 into real of z bar. Okay, that is z bar is x minus iy minus 2 into real of z bar is real of z bar, that is x. Okay, so this becomes x minus 2x is minus x minus iy. Third number, I got the third number. And the fourth number is z minus 2 into real of z, that is x plus iy minus 2 into real of z, that is x, 2x. So this becomes also x minus x plus iy. So these are the 4 numbers I got. If you'll write these complex numbers as coordinate wise, so coordinate of this number will be xy. This is x minus y, and this is minus x minus y, and this is minus x plus y. Yes or no? Yes. So it is already given that these four complex numbers represents the vertices of a square of unit 4 units in the Argand plane. Okay, of the side. Okay, let's draw the figure. We'll draw the figure now. Sorry. Okay, suppose I am trying to plot all those complex numbers first. That is, first point is xy. Okay, that is first number is x plus iy. I am simply taking this point is my. This point is z, which is x plus iy. I am taking this point. Okay. Then then conjugate of z, where it will be lying? Conjugate of z. That means if this is my z, then conjugate of z, that is z bar, will be the image of this complex number z. That means simply it will be here. This is my z bar, which is equal to x minus I bar. Okay, is that clear to everyone? Yes or no? Simply the third point is minus x minus 1. That is, in negative real axis, we need to cover minus x units, and on negative y axis also. Negative y axis also we need to cover these units. Okay, similarly, the fourth point is minus x plus y. Sorry, minus x plus y. So this point will be this minus x plus y. So this is minus x minus y, and this is minus x plus y. Okay, if you join these 4 points, what you will get? We are getting a square or not, guys? We are getting a square or not? Because two adjacent points are the conjugate of each other. Yes or no? That means they are lying, or they are placed at the same distance from a point. Okay, so this represents to a square, and whose it is already given that whose sides is 4 units. It is given that the side is 4 units. Now you need to find the modulus of the complex number. Okay, so if this point is x plus iy and this point is x minus y, so what is the length? Anyone can say what is the length? If this point is x plus yy and this number is x minus yy, then what is the length? This will be 2y or not? So 2y, it is given that 4 units. Yes or no? 2y. You can find now the coordinate, because you can calculate it as coordinate wise also. X, y, x minus y. Okay, so if you try to find the distance between these 2 points, you will get 4 units, or 2y units, which is given as 4. Similarly, here also, from this point to this point, so if you try to find the distance between this point and this point, so it will be 2x units, and it is also given as 4 units, because it is a square and all the sides of a square are same. So here we are getting 2x is equal to 2y. So this is the length of square, and this is also the length of square. That means 2x is equal to 2y is equal to 4 units. That means x is equal to y is equal to 2 units. So here I got x, or the value of x and y. So that means my complex number is actually x plus iy, that is 2 plus 2y. Now I can easily find the modulus of the complex number j, which is on root of 2 square is 4 plus 2 square is 4. That is on root of 8, that is 2. This is the answer. Is that clear to everyone, guys? 2 root. Option C is the correct one. Anyone having any doubt in these questions, you can ask. Guys, anyone having any doubt, you can ask here. It's a very simple question, na? Yes or no? See, again I am explaining these things roughly. 4 complex numbers are represented to the 4 vertices of a square, and whose sides is given as 4 units in the organoid plane. Then you need to find the modulus of that complex. Okay, so first I assumed my complex number as x plus y, and by using my assumed number, I can find all the complex numbers and the coordinates of those points also. Then I plot all the points in the organoid plane. Then I am getting a square whose side is 4 units. Then I equate all the sides of the square as same length. Then we are getting 2x is equal to y. then x is equal to y is equal to 2 units. Then if x and y are 2, then my complex number becomes 2 plus 2y. Then mod z is equal to on root of 4 plus 4, that is on root of 8, 2. This is your answer. Is that clear to everyone? Guys, let's respond in the chat box whether it is clear or not. Everyone, please respond to the chat box. Clear? Yes. Okay. Now let's move to the another thing, that is argument of a complex number. Chalo, theek hai. I'm adding one point here. What is actually argument of a complex number? Argument of complex number. How we can find argument of a complex number? The actual argument is angle. Argument is nothing. Angle with x-axis. Okay, angle with x-axis is called my argument. Suppose you have a complex number here, z. Okay, suppose we are taking this point as p, whose point is actually the complex number x plus I. Right. So how can you find argument of this complex number? Argument is actually if you join this point with the origin, and if this complex number makes an angle with x-axis theta. Okay, if this complex number makes an angle with the x-axis theta, then theta is called my argument. So how can you find the argument? How can you find this theta? Now just drop a perpendicular here. If you drop a perpendicular here, we are getting a right angle triangle. Suppose this point is M. Then if I'll ask you to find tan theta, so tan theta becomes, this length is y, this length is x. So tan theta becomes y upon x. So from here in inverse trigonometry functions, there is the operations we know, that is if tan theta is equal to something, tan theta is equal to x, then theta is equal to tan inverse of x. Okay, remember this thing, this operation. If tan theta is equal to x, we can write theta is equal to tan inverse of x. Similarly, from this we can use this operation here, and my theta becomes tan inverse of y upon x. So this is my argument. Okay, this is my argument. But later future classes also we'll study more about arguments. We'll find argument in each quadrant. This is a general formula, but it will not work in all the cases. So we need to manipulate some things. Okay, so this is the formula. What is argument? Just remember, it's the angle with the positive x-axis or with the x-axis of the complex number. The angle made by the complex number with the x-axis. Okay, is that clear to everyone? Okay, so this is all about your argument. So in the next class, we'll start from argument, how to find argument of any complex numbers. In if that complex number may be present in first quadrant or second quadrant, in third quadrant or fourth. Anywhere it can be, but we will try to find the argument of a complex number in the next class, and we'll also see how to find the polar form and Euler's form. So in this class, what we have discussed, we studied about the Cartesian form. Remember what is Cartesian form? That is z is equal to x plus iy. This is my Cartesian form of the complex number. And also we studied how to find the conjugate modulus. So modulus, if my complex number is z is equal to x plus iy, then modulus of complex number is under root of x square plus y square. And also we learned how to find conjugate. So conjugate कैसे find करना है बेटा? If z is equal to x plus iy, and then conjugate of z will be represented by z bar, and it can be zx minus iy. Okay, and last thing we studied, that is argument. Argument is actually the angle with positive x-axis. Okay, angle with positive x-axis is called my argument, and its formula is theta is equal to tan inverse of y upon x. So these are the concepts we have covered in this class. Okay, chalo, theek hai. So it's time to end your class now. Thank you all. Bye bye. Take care, everyone. Chalo. You can leave now. You have another classes also. You can leave. If you have any doubt, you can ask. ठीक है, चलो, बाय बाय।